All right, guys.
Yes, that's what's so sad.
Trying to catch up here real quick. Oh, I missed something. Those two things. Yeah. All right. So, if I want to create these lists, go to L2, I clear it, go to L3, let me clear that bad boy. Go up to L2, and I want that to be how I capture how far apart the data points are from the mean. So it's going to always be the x's, which are in L1, that's where I just put them, minus the mean, which you got to be 6.5. Kabam.
Okay.
And then I want this guy to square it, so I get rid of those stupid negatives. So it's going to be L2 squared. Kabam. All right. How we doing so far? Some of you guys might have sorted it, so you're just in a different order. Okay, and then how do I sum those? Because that's the next thing I need. Yeah, get out. Go to list. Math. Sum it. And then tell it. And it's holy shit. All right, you finally get 69.
I feel good for myself.
Blah, 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 blah. So anywhere you see this, so this is the difference between, even in algebra, I try to do some problems where I showed students this thing, but in algebra, you're so used to a letter equaling a number and you put it in, you know, if A is 5, all right, anywhere you see an A, put it 5. But I know what that whole string of shit is. It's 69. So anywhere I see that whole thing, I replace it with 69. So I see that, rock barrett. So that's 69. The next level of trouble we had was n always means the size of the group I'm looking at. That's it. It cannot be a decimal because that doesn't make any sense. I got 4.8 people. Okay. I don't want to meet them. So it's 12. And then this is a sample, right? So I had to do the adjustment. 12 minus 1, so I get 11. And when you do 69 divided by whatever, you get that business. Yeah, forever. So on your paper, you can round stuff if you're not done with the problem, but never actually round it until you're done. So I know we don't all vote, but you guys understand if I was off course by 1 degree, 8 hours later, I am who the shit knows. I am way off course because I've just multiplied that mistake by whatever else I did afterwards. That if you round in the middle of a problem and you do more shit to it, you're compounding that rounding mistake. So what I want to do, stupid calculator costs enough money, it should have a lot of memory positions, and the most easily accessible one, I think I showed you already, was the ANS button.
Mm-hmm.
So if I hit square root, second negative, square root of the answer, zoom in a bit. It's going to take the square root of the whole thing that was on the screen, so I don't have to rewrite the whole damn thing. So you should get 2.505. Now just to double check, if I do, how do I double check this? Make the calculator do all the work for me. Stat. Make the calculator do all the calculations for me. Calc. One variable statistics. And thankfully everything looks familiar. Yay. All right, and they all rejoice. Yay. Okay. So anything on that so far. I know that it's going to take some practice to get used to that. Again, you didn't have to use a calculator on this at all. It's just going to take you a little bit longer to do it.
So you said for calculating things, not to round it until you calculate the standard deviation.
Yeah, on your paper you could write 6.27 or something. But you want to do the square root of what it really is.
Because I rounded it to 6.273.
Oh yeah. If you don't round it too much, it'll come out close, about the same. You're good. So, real quick, I don't want to make a huge deal of this. Where'd it go? Oh, good Lord, Jeff. 69 divided by 11, square root of that. But if I do the square root of 6.273, are those exactly the same? Nope, but if you round it, does it come out? Yeah. So if you don't round too much, you should very often be okay. Will you always be okay? Nope. Okay. I appreciate that. Now, here's something a little bit new that I just threw at you because, again, I really passed my evil class. Now watch. This formula makes almost too much sense once you see what it is all about. So when I'm talking about standard deviation, I will often use the word steps. Because if I have data that is really spread out, whoa, that standard deviation is huge. So if I want to walk around the data, I don't want to use little tiny steps because then it's going to take me forever to see it all, right? I want to use some big ass steps to walk around this thing. Where if my data is like this, if I use too big of a step, I miss everything, right? So I often discuss standard deviation with using the word steps. Do not write the word step when I'm asking you a definition kind of question on the test. That's not good enough, right? But as an idea, it's beautiful. If I wanted to go from, stay with me. If I'm standing at a point, let's say there's a giant ruler on the ground, and I'm at point 5. I'm at 5, right? I'm at position 5. And I want to go to position 9. And every step I take is 2. How many steps do I have to take to go from 5 to 9? 2. What'd you do? 9 minus 5. I had to go 4 total, divided by how big each step is. How far you got to go, divided by how big each step is. That sounds sort of like the panel thing, remember? So that's the formula. That's all it says. If I want to know how many standard deviations from the mean to 10, well, how far is that? 10 minus the mean. How far is that to go, divided by how big each step is? That'll be the number of steps from the mean to that data point, right? And let me say this. This is really huge. I know it's a little dinky formula. Let's see. I should have looked up I meant to look up some numbers. Have you ever heard somebody describe how big something is in terms of football fields?
Yeah.
I'm sure you all had oh man, it's about 7 football fields from here to there or something. Something along those lines, maybe? Can you see what that means though? How big is a football field? Anybody watch football at all? 100 yards. 11. Right? So if it's 7 football fields, how far away is that? 700 yards. I love it. So you can use a football field as sort of a tick mark. You have this giant ruler where tick marks are a football field apart. Stay with me now. You guys semi with me? Okay. Or sometimes I think if I want to estimate how tall a room is, I imagine a 6 foot tall person and then see how many people I can stack on top of each other. So I use one person as a unit of measurements, right? So anybody know how tall they are? Anybody? How tall?
5'4".
What? Who's that? 5'4"?
Yeah.
All right. So if I had, I could see how many. What's your name again?
April.
April. I'm sorry. I don't know anybody's name. April. I forget my own. So if I stacked you up on yourself, I cloned you, and I could say how many Aprils tall is this room? Would that make sense? Now I'm not saying, cloning her, stacking her, something, but just the idea to see how many Aprils tall is this room. Does that idea make sense? Yes. Because feet, inches, obviously is a complete and arbitrary choice because if you live in a different country, you don't know what that shit is. Mm-hmm. Right? You actually use things based on 10. Okay, so what this is standard deviation is a natural unit of measurement to use. If it is how far away the points get on average, if I say, well, there's 2 of them between the mean and this, that's pretty far away. So if on average they get 1 standard deviation away, and I see something that if your grade was 2 standard deviations above the mean, you did really well. Does that make sense? Because on average, everybody's grade got 1 step away from the mean, and you are 2 steps above the mean. That's really good. Or 2 steps below, oh shit. Do you guys see this? So standard deviation is like a tick mark on a ruler. And we use it to figure out how far apart things are statistically, right? So if you ever heard something like, it was statistically significant, that means it was far enough away to pass some kind of a test. 1 step is not far enough away. That ain't shit. 3 steps, hello, now we're talking. Now that's like the 7-foot tall dude or the 4-foot tall dude. That is statistically significantly different than what I would expect. You guys semi with me? So this formula is huge. It's huge. So it's the, Z-score formula is what it's called. All a Z-score is the number of standard deviations from the mean to a data point. Do you see how slow I'm talking right now? A Z-score is the number of standard deviations from the mean to a data point. So it's kind of beautiful. We have a natural, so for example, this is the example I was going to look up some actual numbers on. How far away from the sun is the Earth? Anybody know?
1 astronomical
This is
unit.
not 2 light years. It's like 8 light minutes. Huh?
1 astronomical unit.
It's so funny. I was like, it would be awesome if somebody said 1 astronomical unit. So it's 93 million, is it kilometers or miles? I always forget the actual numbers. Because I'm in the US, I think it's miles. And we call that 1 astronomical unit. Does that sort of make sense? No? Do you guys, so the distance we are away from the sun, we treat that as a standard unit of measurement. So then we can talk about Jupiter. How many astronomical units away is it? How many Earth distances is it? That's exactly like football fields, right? Just on a more astronomical scale. So that's exactly what this is. If my data is really short, really tiny, really scrunched up, I want to measure distances using a smaller unit of measurement. Well, what's going to be small if it's squunched up? Freaking standard deviation is going to be small. It's this perfect thing to use for measuring things.
Okay.
Kick ass. So in this example, the data point I'm interested in is 10. That goes in for x because x is all the data points.
Mm-hmm.
The mean is 6.5. Standard deviation 2.0505. What do you guys get when you do that? Do it again, sorry. 1.397. So it's like almost 1.4 steps above the mean. Did you guys see that, Jess?
Can you run it or no?
Yeah, I just did. But in chapter 6, we're always going to round z-scores to 2 places because we're going to use a chart that rounds them to 2 places. All right, maybe. So much shit I'm throwing you. Okay. And then, the actual work to this wasn't that hard. You could have looked at the example on the other side. But the interpretation of what this is supposed to mean, hopefully you guys get this. Maybe. Okay. So, this one is definitely a little bit strange. But let me preface this with a little something else. Ooh, preface. Look at that, Jeff, using some vocab. All right. For a normal distribution, it's always going to have this basic shape. It might be skinnier, it might be fatter. Poor little dude. Let's see if you guys get this. What would the z-score for the mean always be? 0. Because Z-score is all about distance from the mean. The mean is 0 away from itself. Then I can go like 1 step up and 1 step down. Oh, my 2 steps up, 2 steps down. 3 steps up. That's amazing, Jeff. 3 steps up. Okay. Is that all right if I do this? There's something called the empirical rule. It kind of makes sense this thing exists because a normal curve is very rigidly defined. It has to follow this rule. Here's what this means. If I go 1 step up and down, I catch 68% of the data. So men's heights are normally distributed. And I think the mean is 69, the standard deviation is 2.8, but I can't be sure. But I can figure out 68% of all men would be from the mean minus the standard deviation to the mean plus the standard deviation. Do you see what I'm saying? A little bit? So if I know something is normally distributed, I know a lot of shit about that. Within 2 standard deviations, there's going to be 95% of the data. So they made the doors a certain height. Why did they choose the height they did? There's probably a minimum height they want to make a door because they can see what percentage of men would be up here. Can you guys see? 2.5%. You guys see where that came from?
So it goes about their height.
So if I knew what height this was, 2 standard deviations above the mean, if I make the door at least that tall, then only this percentage of men, and some women, but most of men, would have to duck, right? So like, see there, boom, they're out, right? So you don't want to have too many people do that, or else you get some bad PR, right? We're not all hobbits. If we were all hobbits, that'd be a much smaller thing. Be rounder, all that kind of stuff, right?
Hobbits are cool.
Hobbits are way cool. Except for the hairy feet, but you don't need shoes. All right, now with that in mind, that's why I love to ask this kind of question. There's this theoretical business, and then there's this concrete, what do you see kind of business. Now this is not normally distributed necessarily, right? If you ordered them, you can see if it looks normal or not. I don't think it's going to be normal. But let's see, what's the mean? Where'd it go? 6.5, right? What's 1 step down? $3.995. And what's 1 step up? Do it again, sorry.
9.00.
There it is. Now, theoretically, if it was normal, I would expect to catch 68% of the data in there. What percentage did I actually catch? And some of you guys are like, I don't know, man. How the hell do I figure that out? Did I catch the 2? There was a 2 in the data, right? Did I catch it? I love thinking about this like a fish in a net, even though I don't like fish. I didn't catch the 2s, did I? Did I catch the 4?
Yes.
Yes. And what's the last number I caught here? 9s. So how many numbers are we talking about? So I caught all the way from the 4s all the way up to the 9s. How many total numbers is that? No, I got 12 total numbers, but how many numbers did I catch?
5.
9. 9? Out of 12, which is
0.75%.
75%. Kick ass. So it doesn't look like, right there I can tell this doesn't look like it's really normal because it should have been 68% if it was going to be really normal. Rigidly normal, right? Okay. Yes, sir.
68, is that like the base for all of them, or it changes?
If it was perfectly normal, anything that is normal will have 68% within 1 step away. That actually is huge. Has anybody ever been bumped off of a plane?
Yes.
Yeah.
Do you know what bumped means? It doesn't mean that you go on and somebody hits you in the face with their bag.
No.
It means that the airline said,
It's
we
packed.
randomly chose you. Sit down.
Yeah.
Why do people get bumped? Yeah, why do they overbook? To make sure that
all the seats are these.
Yeah, because they're gonna fly the damn plane no matter what. They want to make as much money. So why do they overbook though? Because there's a certain probability that somebody won't come. They won't show up, right? So they overbook it. Sort of like at my old university, they sold 2.5 parking stickers for every spot they had, which explains a lot if you think about it. But they just knew there's a good probability that people will come in the morning or afternoon, and there's that chance. They try to control it. There's going to be an overlap, and there won't be any spots. But they didn't really care that much, I guess. Oh, I got over it. No, I didn't, obviously. Then it became a fact, and we were like, I got a spot. All right. So there was a lot here. There was. All right. So let me do this. Everybody has a practice test, right? Okay. So the last thing we're going to do today is, right now, we're going to make a formula sheet for the final for this next test. Yes. Oh yeah. Well, maybe. I think I have one left. Yes.
Again, white one together? I'm not totally sure. We just looked at 4 start. I just thought it was the last one that was in.
All right.
So that's my.
So let me turn the lights back up. Oh yeah, keep forgetting it's right here.
That was like, and then north of town. I don't want to think about it.
All right. So let's make a formula sheet. Oh, no. By the way, tell me again what a Z-score tells you.
How many standard deviations from the mean?
The number of standard deviations from the mean to a data point. I'm going to ask you that question on every test. I'm telling you that right now. Maybe you will be the class that will finally have more than 50% get it right. I am telling you the question. I have told you the answer. This is what every student always wants. What exactly is going to be on the test? And what's the answer, by the way? I just did that. I have yet to get about over 50% get it right.
And you said, what is the Z question?
Yeah. What does a Z-score tell you? A different way I could ask you is, what would a Z-score of 1.5 mean? It would mean that that data point is 1.5 standard deviations away from the mean. Even better would be above the mean because it's positive. I like it. So if you have a negative Z-score for a test grade, that's bad. Negative means you're below the mean. If you have a negative Z-score for a golf score, that's good. Because you want a low golf score. You guys kind of with me? Not really? Yes?
You have a negative standard deviation.
No. For mathematically, we're squaring and then square rooting. That can't come out negative, right? And just conceptually, standard deviation is how spread out something is. So 0 means no spread. Negative would sort of mean, what would that mean? It's like in itself, like Quade. No, I don't know what that means. Anybody got that reference? Quade? No? All right. Total recall. All right. Anyway, sorry. I'll stop. So yeah, no. The non-goofy answer is no, it can't be negative. Because mathematically, it just can't be negative. Okay. All right. So let's see, what formulas we got? Chapter 1, of course, is no real formulas. Chapter 2, class width, you gotta know how to create class width. How do you create class width? High minus low, so the range divided by number of classes. You gotta know that. So the first real formula I'm gonna let you write down is one you might not even want to write down. And you can put this down. But you know how to calculate average, so if you don't want to write that down, you don't have to. It's so weird. Every time I turn around, it's there. It's like a noose hanging there. And then you got Standard deviation. I'm missing something though. What am I forgetting? I'm forgetting something. So you could put this like this. You could even put it like this. You could put it both ways. Somehow you got to remind yourself that if you don't take a square root, you're not really done. So what was this one again? Variance of a what? Population kick-ass, and that's of course standard ratio over population. And then you can put for a sample. And then of course the formula we just now learned. I gathered. And you can also write it if it's sample data we're working with. Do you see that? S is sigma just for a different group. So I can calculate z-score for a population, or I can calculate z-scores for a sample. The idea doesn't change.
It'd be the same steps.
Well, I mean, sigma and S probably would be different. You see what I mean?
Yeah.
But the work and everything else would be the same. You just put in the appropriate value. Yeah. Anything else? Any other suggestions that I might have left off? Because range you got to know, class width you got to know. Percentiles is not really a formula. You just have to know the procedure of how to get those. Anything else? Any other suggestions?
We need to know how to calculate the outliers.
Oh, there's a whole thing about, I kind of left this up to you guys. So this is not on the formula sheet. What does this mean? Bless you. Anybody know what that means? International quota of rednecks. I'm a non-practicing redneck, I'm allowed to. My father was a pure-blood redneck. I'm a non-practicing redneck. IQR is the interquartile range. So it's the range of the interquartiles, Q3 to Q1. It's like high minus low, very similar. It just goes one step in, Q3 minus Q1. And that, of course, builds up to a way, our first method of identifying outliers would be built off of this. I don't really do too much with that because we're going to build off a better way to figure out outliers using mu and sigma later. Yes?
How many questions are we going to have in that?
Oh, normally like 20 something, like 24. And when I say that, A through something is counted. I always hate it when you got 5 questions and they're all A through J. I'm like, that's not 5 questions. So when I count A, B, C, D. So I'd say roughly it's below 30, whatever the hell's going to come out to. Yeah. Some of them, of course, get a little long. Yes.
Multiple choice question.
Say again?
Multiple choice.
Okay. 2 things on that. You don't want me to make a multiple choice question for you. You do not. If you've only ever had easy ass multiple choice questions, you don't want to see one of mine. Because I hate multiple choice. In fact, what I say, I'm very happy nobody's asked me this question. You do not need a Scantron thing for me, because any math teacher who uses Scantron is not a math teacher. They aren't. I don't know what they are. You need to stop. Right? They're just lazy. What's the most important thing about math is the ideas you use to work something out. The answer almost doesn't mean shit. Of course, you're going to get some points off if you don't get the answer right. But I grade heavier on concept. If you do everything right, and then you go 2 times 3 equals 5 somewhere, you might not lose anything if that's the only mistake you made. Because I grade heavy on concept. Do you understand the process? Do you understand this? I have to kind of assume you know that 2 times 3 is not 5. I'm really hoping. Does that make sense? Or you're the one asking. No, multiple choice, no. I will sometimes do true false like I did on the practice test and some other conceptual questions, but no multiple choice.
Now, what does the IQR stand for again?
Interquartile range. Or it might be inter or inter. It depends on where you are. Yeah. I really want this to make sense. What's the 5-number summary? Low and high. Gather Q4. So the range is high minus low. The inner quartile range is one step in. Q3 minus Q1. And I did point out, where is the inner quartile range on this picture? Where is it? In the box. And what percentage is in the box? 50%. That's why the IQR is sort of important. They want to know the range that tells me where 50%. So if I said the middle 50% SAT scores are from this to this, that's the IQR. The IQR is that range. That tells me 50% is within that range. Okay. But this isn't horribly important, to be honest. The mean and the standard deviation is a kind of an upgrade to this. All right, maybe. So there are a few questions that ask you this in the text because I want you to be aware this exists. Anything else that I might have left off the formula sheet? Any suggestions? All right, I'll let you think about that for a while. Looking at the actual practice test, before I give you guys the answer key, do you guys have any questions from the practice test? Is there a problem you want to try out right now? It's up to you. And by the way, do not turn your practice test answers in. I don't want to see that. I'm going to give you the answer key, right? You don't have to do the practice test at all, right? If you have homework to do that first. But at least look at the practice test to see what kind of questions I like to ask, how I set things up, right?
Can you do number 7?
7. Oh, I gave my last one away. Oh. So I am going to list, just like number 7, you see how I list all the different options?
Mm-hmm.
All right, just so you don't have to you should be able to memorize, but I just list them. What's the difference between cluster and stratified, for example?
All from several clusters.
One whole thing, then one takes like some from each.
Which one takes some from each?
Stratified.
Stratified. And cluster takes all from some groups. So I take
Yeah.
a whole group and a whole group, and I leave some groups out. Yes?
So it says 7 paths of each group.
From each shelter, right?
That would